So particle P here, okay, of mass 2 kilograms, so this is moving with this velocity, okay, with respect to time here, okay. So we've got a general velocity here, and they give us some conditions as well. So there's a t equals 0, the start, we've got the position vector, okay. Part A then, it wants us to find the position vector of r, of p at time t seconds. So what we need is a general sort of formula for the displacement, okay, because they mention the letter r here, and that sort of represents a position vector, yeah. So in vectors, that's what r is. R tells us where it is, the position, okay, and that essentially is the general displacement. What we need to appreciate is that velocity, okay, is the rate of change of displacement, isn't it? So we could say, look, since v is equal to dr by dt, yeah, okay, that's what velocity is, how displacement changes with respect to time. We can put that here, okay, equal to what we've got here, and then we can integrate to get r, okay, so we can separate the variables. We can take the dt up here, okay, and when we separate the variables, we need to have the integrals. So we have 13t minus 3I plus 2 plus 3t squared j dt, okay. So separating the variables, take the dt up there simply, and we'll integrate. Now here you've just got 1, right? It's 1 dr. When you integrate 1, you just get the variable. So 1 integrated, it'll become r in this case, because we're integrating it with respect to r. Okay, and then here we've got to integrate each term here, right? So we get 13t, well, t becomes t squared, so 13t squared over 2 minus 3t, okay, 3 becomes 3t, I, plus then 2t, okay, the constant 2 becomes 2t when you integrate it, and then this is 3t squared, so when you integrate that, it'll become 3t cubed, divide by 3, so it just becomes t cubed, okay, simplified. And don't forget then, when you integrate, you've got to have a constant then of integration, okay, so it's important to sort of have that constant there, all right, and the constant then we can determine, okay, and it will be a sort of a vector, this constant, okay, because if you look at the conditions, they say, look, when t is 0, okay, the position vector r will equal to 2i plus 7j, so you literally put that in there, right, sub it in, 2i plus 7j. Now t is 0, all this will vanish, so you get your c there, okay, so to answer then part A, the general position, okay, will be this plus then this constant, okay, and you just need to then appreciate, because the constant is 2i plus 7j, we can put it in there, we can sort of put the i's together and the j's together, so we'll have the plus 2 there for the I, and then the same here, plus the 7 for the j, okay. Now, so that's part A answered. For part B then, determine the acceleration A of p at time t. So this is part A we've done. Part B then, to get the acceleration, well, we've got to go back to the velocity formula, okay, and you just need to appreciate then what acceleration is. Now, acceleration measures how velocity is changing, yeah? So it's the rate of change of velocity. In other words, we can say A is equal to dv by dt, okay? So we can then get A by simply differentiating this. Okay, so 13t minus 3. If I differentiate that, well, 13t becomes 13, minus 3 just disappears, so you get 13i. Here then, differentiate this, well, 2 disappears, differentiate that, we'll bring the 2 down, so you get 6, so 6t j, okay? So that is the acceleration, okay? And notice in the question it's bolded, so the acceleration vector, okay? Which we've got, and we are finished.